Gave on Wednesday, you might have seen this definition of what a persona is. Now, a persona in the design world is a compromise for never meeting real stakeholders, and it's written by gamblers and liars. Now, you'll be pleased to know that this is not the type of persona that I'm going to be talking about today. Instead, the type of persona that I'm going to be talking about today is the one that we find on the LCA website right here. Now, how many people noticed when they registered that there was this new button? Can I get a quick show of hands? Okay, quite a few people. Good. Now, the problem that we're trying to solve with Persona is this. We want to solve the password problem on the web, no less than that. So that's what we're trying to solve, and especially what we want to move away from is something like this, something you might have seen today, something you might see every day when you use the web, right? The good old username and password form. There are many problems with this. Security is one of them, right? If you've been following the news recently, you will have seen a number of companies apologizing publicly after losing quite a lot of their passwords to hackers. And, you could make fun of any one of them, especially IEEE, for not following best practices and things like that. But the reality of this is that this stuff is hard. It's easy to screw up. And in fact, having passwords for your users is really a liability. If you are going that way, here are the things you have to do, right? You have to hash your passwords using something like bcrypt, script, pbkdf2, one of those complicated things. Then you have to use per user salt values because you can't reuse salt values between users. You have to have a site secret outside of your database so that if your database gets stolen, the attacker is still missing a piece of information. Then you have to have proper password and lockout policies to deter brute forcing of your passwords. And of course, your recovery mechanism has to be just as secure as everything else, otherwise the rest may not exist. But the real problem with this list is this. These are the 2013 password guidelines. I can guarantee you that in 5 years, there'll be even more stuff to do, because this is an arms race between you and the attackers that are trying to steal your passwords. Now, of course, let's be honest about the kinds of passwords that your users will choose. This is the top 1,000 passwords, maybe top 500. And this is not the slide title, the big word in the middle. It's the most popular password. It's a little bit depressing. Now, there's another problem. It's not just about security, and it has to do with conversion rate. If you look at typical metrics for sites, it's not uncommon to see something like this. Lots of people going to your sign-up page, and a lot less people finishing the sign-up process. Now, there can be a lot of explanations for this. You know your site better than I do. But one thing that you should consider is that there is a cost to picking a new username and a new password, or the same username but a different password, just for your site. And a lot of people, a lot of your potential users will have to make a decision. Do I want to remember yet another password, or is this site just not worth it? In other words, that gap is costing you real money. Now, there are existing solutions. Not everybody is using usernames and passwords to log into websites. Here's one that I particularly like. Client SSL certs, right? This is the same type of certificate that you use when you want to expose your site over HTTPS. So you go to a reputable certificate authority, and you pay a bunch of money for some numbers, and then you put that on your server, and that tells to all the browsers out there that your server is legitimate because you paid money for these numbers. Now, you can get a similar type of certificate to put in your browser, and then your browser will hand that over to the various websites that you visit to identify you at those websites. Now, when that works, it's beautiful. It's kind of like SSO for the entire web. You just go to the website, your browser does the rest, and you're logged in. So it's brilliant. How many people, out of curiosity, have used this mechanism to log into a website in the last week? Okay, I don't know, less than 10 people. Last month? Okay, a few more. Last year? Right, still not that many. So it's really hard to actually implement on a web server inside web applications. The support inside browsers is not very good. And the mobile story, multiple devices and stuff, just isn't very good. So almost nobody uses that. Let's talk about something that a lot of people use. The idea of outsourcing your identity to a central authority. Now, these are the two most popular ones, Twitter and Facebook. And of course, there's the obvious problem of what happens to your users that don't have a Facebook account or don't want one, or don't want to log in with Facebook on your website because they think that you're going to know everything about their friends if they do that. Well, that is a problem. But there's another more subtle problem, which is if you are running a business, do you really want to outsource the thing that's perhaps most precious about your business, it's your customers list, to a third-party for-profit company that may change its terms of conditions and exclude some of your users, or may just decide that the service isn't worth running anymore? It's a bit of a risk. But more than that, though, if we're trying to look for a solution for the open web, this is just not it, right? We can't have a private company being the gatekeeper of the internet. What about OpenID? The really great thing about OpenID is that they brought back the idea of federation, decentralization, to the identity space. So in the OpenID world, anybody can be an OpenID identity provider. You can choose who your identity provider is, and you can change identity providers if you want. And in fact, you can also run your own identity provider if you're technically inclined. Now, there are various problems with OpenID. It hasn't seen the sort of adoption that a lot of us would have liked to see. And it has had sort of usability issues. Having a URL instead of a username or something like that is pretty weird for a lot of people. But the reason why Mozilla couldn't get behind OpenID and adopt that as its solution is that OpenID has a very serious privacy flaw. And the best way to explain it is to use an analogy. Imagine that when you last checked into a hotel, and when they ask you for a piece of ID to make sure that the name matches the one on the reservation, imagine if they took your driver's license and then phoned up the government that issued it, right, just verifying that it's valid. Well, that would give that particular government department a trail of every hotel you've ever checked into, which is a little bit creepy. But also, it would allow that government, based on other information that they have, such as, I don't know, maybe you have a student loan that you haven't fully repaid yet, it will allow them to say, well, that student loan you haven't fully repaid, now you're traveling to this other country, and, no, we'll just deny you that stay. You should focus on paying your debts, and after you're debt-free, you can stop going to backpackers. It's a bit of a stretch, but the point here is that that's exactly the kind of power that we give to an OpenID identity provider. So unless you are running your own identity provider, that really affects you. So storing passwords is hard. It's a big mess. And there are no real suitable alternatives for the open web. And that's why we decided to build Persona. Now, Persona, just like OpenID, is a decentralized system. Anybody can be their own identity providers. You can change identity providers if you want, etc. So it's also federated. It is privacy sensitive. So we put the browser in the middle of the chain. So the browser is your trusted intermediary because the browser already sees every website that you're logging into. So it's not a big deal. And we want this to be really simple. Simple both for developers, because if it's not simple for developers to implement, then it's never going to be secure. And we also want to make it simple for users, because if it's not simple for users, then sites are not going to adopt it. So we have a really strong focus on user experience. And finally, of course, like everything else that Mozilla does, this system is fully open source. Now, this is identity in your browser. We want to make the login system of authentication be part of a standard, we want this to be a standard part of the web browser, of all web browsers. It's not a Firefox-specific thing. It should be baked into the web. How does it work? Well, if you only remember one thing from this presentation, it should be this. Persona is based on a concept of a verified email address. Now, I have an email address. Here's one of mine. And I have some kind of proof that proves that I own it. And that's all I need to be able to identify myself consistently when I visit websites. How do you get such a proof of ownership? Well, in the system, the authority for whether or not you own a particular email address is, of course, the email address provider. So if you have, I don't know, like a Gmail address, then the authority for that would be gmail.com or mail.google.com. And so the way you get this proof that you own that email address is by simply going to your email provider. So say you log into your webmail, type in your username, your password, you do the whole two-factor auth thing, and then you log in. At this point, the browser will generate a public and private key specific to that identity, and then it will send the public key over to the email provider. The email provider knows who you are because you're logged in, and so at that point, it can sign your public key and return it to you. Now, when I say you, it's your browser. You don't actually see any of that. It happens transparently. This signed public key is what we call the certificate. That's a proof that you own the email address, and it's signed by the authority for that email address. And so the browser stashes this certificate somewhere safe. And so what you have is a signed statement from your email provider that you control this email address. Now, it's very similar to how we use passports for international travel. Because if you want to travel to another country, first thing you have to do is you have to go to your passport office to get a passport, and then you take your passport home, store it somewhere safe. When you do go and enter a new country, then you present your passport and you're let into that country. So the act of getting a credential and using a credential, those two things are separate. So here's what we can do with that certificate that we got proving that we own an email address. This is a demo site that we run, 123done.org, and it's got a button at the top there, sign in with Persona. So I'm going to click on this, and there's a pop-up window that shows on the left all of the email addresses that I have certificates for. So I'm going to pick the second one, and then click sign in. So these certificates are in my browser. And there we go. I'm logged in, if you see at the top there, as that email address. So that's all the user has to do to use Persona. It's like 2 or 3 clicks, and they're in. That's it. So simple as that. From the point of view of the website that you're trying to log into, so in this case, we'll log into the LCA website using Persona, then what happens is that the user sends what is called an assertion. Now, an assertion is a cryptographic bundle that contains 3 things. It contains, first of all, the certificate that you got that proves that you control that email address. Then it contains an audience and an expiry. So the first thing that the site will check is the audience. The audience is the URL of the website that you're trying to log into. Now, the reason why you want to have that in the assertion is that if you had sort of a generic assertion that wasn't specific to a particular audience, then the LCA website could turn around and then log in as yourself, impersonate you onto another website that uses Persona. But that's not going to work because that other website is going to check the audience and we'll get an audience mismatch. That's the purpose of that field. Second one is the expiry. By default, assertions are valid for 2 minutes, so it's just enough time to log you in, but after that the assertion becomes useless. And finally, we need to check the signature on the certificate. So how do we do that? Well, this is just simple public-private key cryptography. And in order to check the certificate that was signed by the email provider, we need to go to the email provider, grab the public key, and then we can check the certificate with that. Now, notice that when you grab the public key from the email provider, that's a site-wide key or domain-wide key for that provider. It's not specific to the user that is trying to log into your site. So you're not revealing anything by grabbing the public key. And in fact, you probably, if it's Gmail, you probably already have a cached copy of that public key because it's likely that more than one user on the LCA website has a Gmail address. Once you've verified that, then everything is valid and you can log the user in. So Persona replaces the password check, but all the rest of session management is the same. You can set your cookie and do whatever you do normally. Now this is a vision of how the system works. There's a big elephant in the room, and that is that if we want the system to work exactly like what I've shown, we need the cooperation of all of these people, right? We need all of the emails provider to be on board. We need all of the browser vendors to be on board. Okay, let's take them one at a time. Let's start with email providers. This is what we want to see. If I've got a Gmail address, it will be signed by Gmail. My certificate will be signed by Gmail. Now, Gmail doesn't support Persona natively yet. If you do work on Gmail and you want to talk to me about that, please do after the talk. But what we have in the meantime is this. We have a certificate signed by persona.org. So in essence, what we have is we have a fallback identity provider. If the domain that you're using doesn't support Persona natively, we fall back to persona.org. The reason why we can sign certificates on behalf of other email domains is simply because the first time you use Persona, we send you an email as part of the registration process, and then it's got a unique link, or a link with a unique token in it. When you click on that, that proves to us that you control that email address. So it's a pretty normal way of checking that. That's what pretty much everybody else does on the internet. And so that's what we do. Now, of course, we don't want you to have to click on an email link every single time you log into a website. So what we do is we create an account for you on that fallback identity provider. And so you don't have to do that every time you want to log in. But what the fallback gives us is that today we support all email providers. So the system is ready to go. We don't have to wait for these people to get on board before we can start using it. But as they get on board, then the system becomes more and more decentralized. Now, the second piece is a little bit trickier. How do we get this inside the browser? Because, as I said, we want this to be a browser feature. We don't want something that's tacked on to the web. This is what we want. We want a new API directly onto the DOM. So navigator.id, whatever, is what we want to achieve. So we could do maybe an add-on, Firefox add-on, Chrome extension, and get people to try to install that. That's quite easy to do. But if you try to convince a site to use Persona as their only login system, then they may ask embarrassing questions like, well, how many users have actually installed the extension? Does that mean that I've only got a 5% chance of having a user successfully log into my site? So not a very good solution for this kind of thing. Another thing we could do is we could build it directly into Firefox, because we're Mozilla and we have people that work on Firefox. But that's kind of, it's better, but it's still like what, a quarter to a third of the browser market? It's not enough. You need a whole lot more if you want to have a credible solution. Well, it turns out Chromium is an open source project as well. We could send patches there, and eventually they would make it to the Chrome web browser. Well, that may be true, but we're still missing a couple of browsers. We're still, at most, 2/3 of the browser market, probably less. So not a very good solution either. What we did, in the end, is we used this little-known language called JavaScript to build a complete implementation of Persona in JavaScript. So it works in all modern browsers on desktop, and it works on all of these mobile browsers as well. Did I say mobile first time? Desktop on top, and mobile at the bottom. So that's what we get from using JavaScript to do all of this client-side crypto stuff. Now, if you're interested, this pattern of developing a browser feature and starting with a JavaScript implementation or a JavaScript fallback like this is something called LIFT, for Locally Isolated Feature Domain. Now, the acronym is not super important, but the idea here is that we want to get trusted code executing in the browser. And the way to do that is there's a couple of tricks to it. First one is we have a domain name. That's the domain name that's hosting the JavaScript implementation of Persona for your browser. So the code runs on there, and it uses something called local storage. Now, local storage, for those who don't know, is a very simple key-value store that's built into all modern browsers, and you can easily store and retrieve strings from it. And the particular feature that's interesting to us is that local storage is tied to the domain on which it's executing. So if you have code running on login.persona.org that saves a secret key to local storage, that secret key is only readable from code that's running on that domain. So anybody using Persona on their site can't get to your private key because the private key is only accessible to that domain. So that's why we use local storage. Now, of course, we do need other people, other sites, to interact through a restricted API with the crypto stuff that's stored there. So we use for that post message. Post message is a standard mechanism that web browsers have to do cross-domain message passing. And so we have an API that's built using this. Now the picture looks like this. So we have the site that's trying to use Persona for logins, LCA in this case. We have a post message channel, and then which talks to Persona, which is the only thing that has access to the local storage stuff. Now, just before I give you a little demo of it, are there any questions, sort of burning questions, that prevent you from understanding what I've explained so far? There's a couple? Okay. Just yell them out and I'll repeat them.
Hi, I happen to work for an email provider, and I'm a little bit interested about this thing where you provide something that claims to verify one of